Welcome back to the deep dive. I want to start today with a bit of a confession.
Oh, we're starting with confessions now.
Just a small one. I was looking at my screen time report this morning, which is, a horrifying ritual in itself. And I realized something about the last 4 years. You
Okay.
can't just
If
use
you look at
grammar.
the apps I use,
guess
the
the
news
news I
randomly.
read,
You have
the
to
emails
understand
I
the
get. There are two letters that have essentially, colonized my digital life.
Let me guess. A
And I. And honestly, I'm exhausted by it.
you and everyone else. It's a kind of ambient noise now, isn't it?
It is. It feels like we are drowning in it. You open a recipe app to bake cookies, and there's an AI chatbot wanting to optimize your dough.
Right.
You open a spreadsheet, and it wants to analyze the rows. It is relentless. And looking at the stack of research we have today, specifically this conversation from Urgent Futures with Jesse Damiani, I think we have to address that fatigue head on because we're all just so tired of the hype.
We are. But here's the thing about fatigue, and it's a dangerous thing. It can make you complacent. You stop paying attention right at the moment when the thing becomes most dangerous or, most useful.
And that's the tension I really want to explore today. Because we've been here before, haven't we? Or at least it feels like we have. Remember 2021?
I try not to.
Come on, the metaverse. We were all supposed to be buying virtual real estate. I mean, that was the future, right?
Right. We were going to live in headsets buying NFTs of, what were they, bored monkeys? And attending meetings as these sort of legless avatars. It sounds absurd now.
It sounds completely absurd. And if you were a skeptic back then, you were right. That bubble popped. It fizzled out.
Yeah.
So the natural human reaction when we see this AI wave is to say, okay, this is just the metaverse 2.0. It's loud, it's annoying, and it'll go away when the VCs get bored.
But that is the fatal mistake.
Yeah.
And the source material today, this interview with Timothy B. Lee,
Yeah.
makes a distinction right out of the gate that I think is worth the price of admission alone.
Which is?
The difference between speculation and dominance. The metaverse was a speculative bet on a future behavior, that we would want to wear headsets, that we'd want to live in that world.
A bet that didn't pay off.
Not at all. But AI isn't speculating on behavior. It has achieved, and I'm quoting the source here, a level of market dominance that almost defies imagination.
Defies imagination. That's a heavy phrase. It suggests we aren't just talking about a popular app like TikTok or, Instagram.
No, we're talking about infrastructure. Think about it. The metaverse required you to go out and buy a $500 device, put it on your face, and completely change your entire daily habit loop. It was a destination you had to consciously choose to visit.
And usually I chose not to visit it because the headset gave me a headache.
Exactly. It had friction. Massive friction.
Yeah.
But AI has zero friction. It's slid into the software you were already using.
Yeah.
It's in your word processor. It's in your search engine. It's in your customer service chats. It didn't ask you to move. It moved in with you.
Wow.
And that's why the dominance is so staggering. It's not a trend. It's a utility layer that just got poured over the entire digital economy.
That's a terrifying distinction. One is a destination, the other is a utility. Like electricity versus a theme park.
Precisely. You can choose not to go to the theme park.
Yeah.
You can't really choose to opt out of electricity. And because it's a utility, you can't just ignore it. You could choose not to buy an NFT.
Right.
You can't really choose to ignore a technology that is reshaping the economy, the job market, and the very flow of information itself, as the source puts it. Whether you like it or not, it's in your best interest to understand how it actually works.
Whether you like it or not. That sounds almost like a threat.
Or a wake-up call. I think that's how we have to see it.
Fair enough. So if we accept that this isn't going away, we need a guide. And this is where I got really interested in our guest expert for this deep dive, Timothy B. Lee. Because usually when we talk about AI, we get one of two types of people.
You get the hype man or you get the doomer. The sky is falling or we're all going to be immortal.
Well, I was going to say, you get the journalist or you get the engineer.
Ah, right. That's the classic divide, the two cultures.
Exactly. You get the journalist who can write a beautiful story but thinks algorithms are basically magic spells. They can describe the feeling of the tech, the societal impact, but not the nuts and bolts.
And they can get the details wrong, which is a big problem.
A huge problem. Or you get the engineer who knows the math intimately, but falls asleep if you ask them about the economic impact or the policy implications.
It's the two cultures problem, right? You have the humanities people and the science people, and they speak fundamentally different languages. But Timothy B. Lee is a unicorn because he speaks both.
He really is. I was looking at his bio in the notes for today. On one hand, he's a veteran reporter, Washington Post, Vox, Ars Technica. He's been covering tech policy and economics for over a decade. He knows how to construct a narrative. He knows how to interview a senator.
He knows how the world works. But then you look at his education.
A master's degree in computer science from Princeton.
Which is, I mean, that's not something you just pick up on a weekend course. That's serious technical depth.
No. And that specific combination high-level storytelling plus Princeton-level computer science is exactly what we need right now. We need someone who can open the black box of AI, look at the actual math, and then turn around and explain to us in plain English what that math means for our jobs, for our society.
Precisely. And he launched his newsletter, Understanding AI, specifically to bridge that gap. And that's what we're going to do today. We're going to borrow his brain. We're going to move past the AI will kill us headlines and the AI will save us headlines.
Yeah.
And we're going to look at the mechanics.
We're going to look under the hood.
We have to, because the engine is running and the car is moving very, very fast.
Which brings us to our first big theme, the speed. I mean, the podcast episode itself is called Urgent Futures, and there's a related article in our stack titled The Tsunami is Already Here. I want to pause on that word. Tsunami.
That's a vivid image, isn't it?
Right.
Very powerful.
It is. But why a tsunami? Why not a storm? Or, an earthquake? I feel like we use these disaster metaphors a little loosely sometimes.
Well, think about the physics of a tsunami. It's actually a very, very specific choice of metaphor. It's not loose at all.
Okay, take me back to earth science class.
A little bit. A storm happens on the surface. Wind blows the water. You get these big choppy waves. It's messy. It's loud. But deep down, the ocean is relatively calm.
Okay.
That was the metaverse. That was crypto. It was surface turbulence. If you were a deep-sea diver, you might not even notice the storm raging above you.
Okay, so surface chop versus deep water. I get that.
A tsunami is different. A tsunami is caused by a displacement of the seafloor, an earthquake, a landslide. The entire column of water moves from the bottom all the way to the top.
Ah.
It carries this massive, silent energy, and it travels at the speed of a jetliner across the open ocean. You often don't even see it coming until it hits the continental shelf and rears up.
So you're saying AI isn't just surface drop, it's a fundamental displacement of the entire ocean.
That's the argument. It's displacing the fundamental layer of how we process information, how we create, how we reason. And since the modern economy is information, well, you get the picture.
The entire water column is moving. Wow. That really explains the urgency in urgent futures.
Right. With a steam engine or with electricity, we had decades to adjust, generations even. You could live your whole life during that transition. With AI, specifically the generative AI boom of the last, 36 months, the adoption curve isn't a slope.
It's a cliff.
It's a cliff. We jumped off.
And we don't know where the bottom is.
We don't even know if there is a bottom. Which leads to this other concept from the source list that I found fascinating, a little bit unnerving.
What's that?
It calls AI our ultimate test.
The ultimate test and greatest invitation. Yeah, I saw that. Let's unpack the test part first. What are we being tested on? Is it a test of our intelligence? Like, can we build a machine smarter than us and not get destroyed by it?
I think it's deeper than that. I don't think it's about raw IQ. I think it's a test of adaptation. Look, humans are fundamentally tool builders. That's our thing.
Right.
We build tools to overcome our physical limitations. We are weak, so we build cranes and levers. We are slow, so we build cars and planes. We have limited memory, so we invented writing and hard drives.
Okay. So far, so good. We're great at that.
But we have never, ever built a tool that overcomes the limitation of thinking. We have never managed to scale reasoning itself.
We've scaled muscle, but not mind.
Exactly. And that is the test. What happens to the human animal when thinking, or at least a very powerful simulation of it, becomes a cheap, abundant commodity? When you can click a button and get a B- essay, or a functioning piece of code, or a diagnostic analysis of an X-ray, what is left for us to do? What is our unique contribution?
That's the existential dread kicking in. I feel it.
It is. It's a huge question.
Yeah.
But that's where the second part of the phrase comes in, the greatest invitation. And I think this is where Timothy B. Lee's perspective is so refreshing. He doesn't see it purely as a replacement. He sees it as a platform.
A platform for what? What are we being invited to do?
We're being invited to operate at a higher level. If the machine can handle the prediction, and we'll get to what that word really means in a second, then the human is invited to handle the meaning, the judgment, the ethics, the creativity.
Okay, but that assumes we want to handle meaning. Sometimes I just want to get the boring email written so I can go home.
That's a fair point, a very human point.
Yeah.
But think about the urgent future framing again. If the tsunami is already here, you can't stop the water. You can only learn to swim.
Right.
And the first step to swimming, the first step to passing this test, is to stop treating AI like a magic trick. You have to pop the hood.
You have to understand the mechanics. You have to know why the water is moving in the first place.
Exactly.
Yeah.
Which is the perfect segue. Because I think 99% of people, myself included some days, use these tools, ChatGPT, Claude, whatever, and we treat them like magic 8 balls. We type in a question, we get an answer, and we assume there's a little smart person inside the computer. The homunculus fallacy.
What?
The homunculus. It's an old philosophical idea, the little man inside your head, or in this case inside the computer, who is doing the actual thinking.
Right. But you're telling me, and Timothy B. Lee is telling us, that there is no little man. There is just prediction.
Just prediction. That's all there is.
Okay, let's get into segment 2. The science of prediction. I really want you to break this down for me. The source material uses this title. How is AI changing the science of prediction? And when I hear the word prediction, I think of the Weather Channel. 40% chance of rain tomorrow.
And that is exactly where you should start, because that's what prediction used to be. Traditional prediction is about structured data, numbers. Actuaries predict when you'll die based on tables. Meteorologists predict rain based on atmospheric pressure data. Economists predict inflation. Usually badly.
Usually very, very badly.
But that was all structured data, numbers in, numbers out. What changed with AI, specifically with large language models or LLMs, is that we figured out how to treat language like a math problem. We turned words into numbers.
Treat language like a math problem. Okay, how do you do that?
Imagine you were playing a game, a very simple game. I give you a sentence, but I cut off the last word. The cat sat on the...
Mat.
Why did you say mat? You could have said anything.
Because that's the phrase. It's always the cat sat on the mat. It's a nursery rhyme.
Right. But technically it could have been the cat sat on the sofa,
Yeah.
or the cat sat on the newspaper, or the cat sat on the moon.
Sure, but mat is the most likely. By far.
Exactly. Your brain, based on years and years of reading and hearing English, assigned a higher probability to the word mat than to sofa, and a much, much higher probability than to moon. You made a statistical prediction based on your training data, which is your entire life experience.
Okay, I follow. I'm a prediction engine. My brain is, anyway.
You are. We all are. Now, imagine a machine that has read not just your life experience, but everything. Every book ever digitized, every Wikipedia page, every Reddit thread, every line of code on GitHub, the entire public internet.
That's an unimaginable amount of data.
It is. And we give it a much harder sentence, something like, the primary implications of the 2008 financial crisis on current federal housing policies suggest that.
Okay, to finish that sentence, you need to know about the 2008 crisis, you need to know about housing policy, you need to know how banking regulations work, and you need to know how to construct a logical, coherent argument.
Yes.
Yeah.
You need all of that context. And here is the truly mind-bending part. The AI doesn't know those things in the way you and I do. It doesn't have memories of Lehman Brothers collapsing. It doesn't own a house. It hasn't lived through a recession.
So how does it answer? Because when I ask it a question like that, it gives me a really good answer. It sounds like a PhD economist wrote it.
It answers by looking at the statistical relationships between tokens.
Tokens? What are tokens?
A token is just a chunk of text. It could be a full word like house, or just part of a word like ing. The model breaks everything down into these little pieces. And it knows that in the context of 2008 crisis and housing, the tokens subprime, liquidity, Dodd-Frank, and regulation appear with extremely high frequency and in very specific structural patterns.
So it's pattern matching.
It's predicting the next token, one at a time, based on a probability map that is so incredibly complex, so multidimensional, that the output looks like reasoning.
So it's basically autocomplete on steroids.
That's the common analogy. And it's not wrong, but Timothy B. Lee would argue it's a bit reductive. It's autocomplete, yes. But if your autocomplete has read the entire Library of Congress and understands the deep logical and grammatical structures of how concepts connect, then at a certain point prediction becomes indistinguishable from intelligence.
But wait, indistinguishable from intelligence? That's a huge claim. Are you saying it understands what it's saying? Or is it just the very, very sophisticated parrot?
That is the trillion-dollar philosophical question that people are debating right now. But from a purely practical standpoint, from the standpoint of how does it actually work, it is finding the most probable path through a high-dimensional map of language.
A high-dimensional map? That sounds complicated.
It is, but there's a classic example that makes it clear. Imagine a map where words that have similar meanings are located close to each other. King and queen are close together. Man and woman are close together.
Okay, I can visualize that, like cities on a map.
Exactly. And the relationships between them are also mapped. So the distance and direction from king to man is the same as the distance and direction from queen to woman. It represents the concept of gender.
Okay.
So the model can use that geometry to navigate. If you give it the equation king minus man plus woman, the model starts at king, moves along the vector that represents removing maleness, then adds the vector that represents femaleness, and it lands on
Queen.
Exactly. It didn't think about royalty or gender. It did vector math. It just navigated a map of meaning. And it turns out if you have a big enough map with trillions of these connections and you've trained it on all human knowledge, that vector math can pass the bar exam, write beautiful poetry, and debug Python code.
Because all of those things, law, poetry, code, are just predictable structures of language. They have rules.
Exactly. They're all just systems of tokens with statistical regularities. Logic is predictable. Grammar is predictable. Rhyme schemes are predictable. So AI has turned the qualitative world, the world of ideas, of art, of law, into a quantitative problem.
And that's why it's a tsunami, because math scales.
Math scales infinitely. You can throw more chips, more data, more electricity at math. You can't just throw more chips at a human lawyer to make them twice as smart or twice as fast.
And this really explains why Timothy B. Lee's background is so crucial for this moment. A journalist sees the output, the poem, the legal brief, and sees either magic or an existential threat.
Right.
A computer scientist sees the input, the vectors, the weights, the probabilities, the math. Lee sees both.
He sees the matrix. He sees how the math produces the magic.
He sees the matrix, and because he sees it, he's not afraid of it. He's not mystified by it. He knows it's just math.
And knowing it's just math is the absolute key to the next part of our discussion. Because if it's just math, if it's just a tool for predicting the next most likely token, then it's not a god. And it's not a devil, it's an engine.
And engines need operators. They need drivers.
Exactly. If you have a Ferrari engine, it doesn't matter how powerful it is if you don't have a steering wheel, brakes, and a person who knows how to drive.
Which brings us to segment 3, symbiotic intelligence. This is where the source material gets surprisingly optimistic. And honestly, I think we all need a little optimism right now because the whole tsunami and ultimate test talk was getting me down.
Well, grab onto this life raft then. The source specifically references this idea of symbiotic intelligence, I think in connection with a guy named Nathan, and it features Reid Hoffman discussing why AI is good for humans.
Reid Hoffman, the LinkedIn guy. He's usually pretty plugged in. He's not one for, baseless hype.
No, he's a serious thinker. And his take, which aligns perfectly with Timothy B. Lee's analysis, revolves around this idea of symbiosis.
Define that for us, because in biology, symbiosis can be, well, it can be weird, like parasites living on a host. That doesn't sound good.
True, but we're aiming for mutualism, a relationship where both parties benefit. The classic example is the clownfish and the sea anemone, or the bee and the flower. In this case, it's the human and the machine.
Okay, so instead of the old narrative of AI replaces human, it's human plus AI is better than either one alone?
Right. Think of it as a centaur, half human, half horse, an entity that combines the best of both.
I've had that term used in chess. Centaur chess.
Exactly. That's the perfect laboratory for this idea. For a while now, in chess, a reasonably good human player, combined with the powerful computer program, can often beat the best standalone computer. And they can certainly beat the best standalone human grandmaster.
How does that work?
The human provides the long-term strategy, the intuition, the why. They see the whole board and have a sense for the flow of the game. The computer provides the flawless tactical calculation, the brute force, the how. It checks millions of moves a second and makes sure the human doesn't make a stupid, predictable blunder.
So the human steers and the computer provides the horsepower.
Perfect analogy. Now, how does that apply to my job, or your job, or the listener's job?
Yeah, let's make it practical.
Well, let's go back to the prediction engine concept we just discussed. What parts of your job are fundamentally predictable?
Writing boilerplate emails, scheduling meetings, summarizing long, dense documents, finding a bug in a piece of code. Honestly, a lot of it. A huge chunk of my week.
Right. The drudgery. The boilerplate. The stuff that makes you feel like a robot. The argument for symbiotic intelligence is that we should let the robot do the robot work.
So I become the manager of my own personal robot assistant.
You become the editor of the robot. You become the conductor of the orchestra. If AI can generate a solid first draft of a report in 10 seconds, you don't have to spend 3 hours staring at a blank page, paralyzed.
The dreaded blank page.
Exactly. Instead, you spend 30 minutes refining that draft, adding your specific expertise, your unique voice, your ethical judgment, your human touch.
So the invitation we talked about earlier, the greatest invitation, is an invitation to skip the blank page phase of everything.
It's an invitation to operate at a higher level of abstraction. If you're building a cathedral and you have a machine that can lay bricks perfectly, you don't have to spend all your time mixing mortar and laying bricks. You can focus on the architecture. You can think about the design of the stained glass windows.
I like that. That sounds empowering. But I have to play devil's advocate here for a second.
Please do. This isn't all sunshine and roses.
If the AI lays all the bricks, doesn't the apprentice bricklayer lose the chance to learn how to lay bricks? If I never write a bad first draft myself, do I ever learn how to be a good writer? Do my skills atrophy?
That is the danger. That is the core atrophy argument. And it's a very real risk. Symbiosis requires us to be vigilant and intentional. We can't just passively outsource our thinking. The goal is to outsource the execution while retaining the understanding.
And that ties back perfectly to Timothy B. Lee's whole mission, understanding how the tool actually works. If you don't know that the machine is just a prediction engine, if you don't know it's just doing probability, you might trust it too much. You might let it be the architect and the bricklayer. You might just accept its first draft as gospel.
And that's when the building falls down. Because remember, the AI doesn't know truth. It knows probability. It will confidently hallucinate a fact or a legal precedent because that fact sounds statistically likely. It's a plausible sounding sequence of tokens.
It sounds true, so it predicts it as the next token.
Exactly. A good symbiotic partner knows the limitations of their partner. You wouldn't ask a fish to climb a tree. You shouldn't ask an LLM to be a source of absolute unverified truth.
So symbiosis isn't just a passive letting it do the work. It's an active, critical partnership. It's a constant dialogue.
It's a dance. And if you step on its toes or you let it lead you off a cliff, well, that's on you, the driver.
This leads perfectly into our final segment, because if we are going to be symbiotic partners with these tools, we need to know who we're partnering with. And right now, there are a lot of people out there trying to sell us some very bad dance partners.
Yes, the grifters and the hype merchants.
Segment 4, separating hope from hype. The source material explicitly lists this as a key theme. And given that this is, as we said, the buzziest tech category ever, the hype is deafening.
It's completely off the charts. Every single startup has .ai in their domain name now, whether they're using AI or not.
Exactly. So how do we, as users, as consumers, as business owners, distinguish between the market dominance that is real, the actual tsunami, and the bubble that is just, surface foam?
This is where we need to put our economics hat on.
Oh, foot.
One Timothy B. Lee wears so well.
Okay, my economics hat is on.
The filter is actually pretty simple. It's utility versus speculation.
Break that down for me.
Speculation is, this might be incredibly useful someday, so give us $1 billion now. That was the metaverse in a nutshell. Buy this virtual land because everyone will be here in 2030. It's a bet on the future.
And utility.
Utility is, this solves a real, tangible problem I have right now today.
Like, help me write this complicated SQL query, or summarize this 2-hour meeting for me.
Exactly. The reason AI has achieved true market dominance, unlike crypto or the metaverse, is because the utility is immediate and personal. You use it, you get a useful result, you save time, or you create something new. The feedback loop is instant.
So if a company is promising you a future revolution but can't show you a current concrete utility, that's a big red flag for hype.
That's a massive red flag. Hype ignores costs and focuses on an imaginary future. Hype says, we are going to build an artificial general intelligence that is smarter than Einstein and will solve climate change.
And hope?
Hope says, we built a model that helps radiologists spot tumors 15% more accurately. Or, we built a tool that reduces common coding errors by 30%.
So boring is good.
Boring is profitable. Boring is real. The science of prediction is actually quite boring when you get down to it. It's just statistics and linear algebra. The hype tries to make it sound like we're summoning a magical genie.
So Timothy B. Lee's advice, I'm guessing, would be, look at the economics. Does the value created by this AI tool exceed the very real cost of running it?
Exactly. We forget this part. Running these massive models is incredibly expensive. It burns a shocking amount of electricity. It requires massive, specialized data centers that cost billions to build. If the prediction isn't valuable enough to pay for that electricity bill, it's a bubble. It's not sustainable.
That's a really grounding way to look at it. It takes all the sci-fi out of it. It's not about, will the robots take over the world? It's about, is the electricity bill for this query worth the output I'm getting?
At the end of the day, for a business, it's always about the electricity bill.
So let's try to synthesize all of this. We've covered a massive amount of ground today.
We really have.
We started with the tsunami, the realization that this isn't a surface wave like the metaverse. This is a fundamental displacement of the entire information economy.
The whole water column has moved. There's no going back.
Then we dove into the engine, the science of prediction. We learned that the intelligence we see is actually just high-dimensional vector math, predicting the next most likely token.
Which demystifies the ghost in the machine.
It's not math.
Say it's math.
Then we looked at the goal symbiotic intelligence, the idea of the centaur. Using the machine to handle the predictable drudgery so that we humans can handle the meaning, the judgment, and the creativity.
But doing so with vigilance. Being an active driver, not a passive passenger.
And finally, we talked about the trap confusing the hype with the hope, and the need to use a simple economic filter, utility, to tell the difference.
It's a full toolkit for survival in this new ocean.
If the listener walks away with just one single thing from this deep dive today, what do you think it should be?
For me, it has to be the core definition of AI as a prediction engine. Once you really truly internalize that this is a tool for navigating probability, not a source of absolute truth, it changes everything about how you use it. You stop being a passive consumer of magic, and you start being an active operator of a very powerful machine.
You take the wheel.
You grab the steering wheel with both hands.
For me, it's the urgency. The idea that we don't have 10 years to sit back and figure this out. The tools are being deployed right now. The economy is shifting under our feet right now. As the source said at the very beginning, it's in your best interest to understand how it actually works.
Ignorance is no longer an option. It's a liability.
So, the call to action is clear. Don't just read the scary headlines. Read things like the Understanding AI newsletter. Listen to the experts like Timothy B. Lee, who can explain both the code and the context.
Treat it as a continuing education course that never, ever ends.
And I want to leave you with one final thought. We talked about AI being our ultimate test. We usually think of tests as things that we pass or fail individually. Did I keep my job? Did I learn how to do prompt engineering?
But maybe the test is bigger than that. It's not an individual exam.
Exactly. If this technology is a tsunami that reshapes the entire global landscape, maybe the test isn't about intelligence at all. In a way, we've solved for intelligence. We've built the ultimate intelligence engine. We have figured out how to scale smartness.
We have. On a planetary scale.
But we haven't scaled wisdom. We haven't scaled ethics. We haven't scaled kindness or foresight.
No, those are still strictly human and very scarce resources.
So maybe the ultimate test is this. Now that we have built the ultimate engine of intelligence, can we operate it with enough wisdom to keep the car on the road?
That is the question, isn't it?
Right.
We've got the horsepower. Do we have the driver?
Something to think about next time you see those two letters pop up on your screen. Thanks for diving in with us.
Until next time.
Keep swimming.